Hello, this is Mr. McGovern. This is the fourth video in the capacitor series, and we're going to look at the idea of charging and discharging a capacitor. So I'm going to go through a simulation and talk about what happens to the current in the circuit and the voltage in the circuit while we charge and discharge the capacitor. So what do we mean by that? So here's another simulation. I've got two circuits with a switch in them. So there's a battery. When I close this switch, I've got a loop here, which means the current will flow and we'll get charge build up at the capacitor. And after that's charged, then we can undo the switch and close the switch, and this will allow us to discharge the capacitor. So in this one here, we go through that so we can see the first circuit, and I'm going to go and close that switch, and you can see it charges up, and as it charges up, the bulb goes on for a while. I can undo it. This is now full of charge. Close the circuit down the bottom, and the bulb goes bright while this discharges down here. So we want to be able to talk about and graph the, explain the shapes of graphs of both the current and the voltage in a charging circuit and a discharging circuit. So in the charging circuit, what I've got is I've got a current meter. This is an oscilloscope. So it measures current as time goes along. So I close the switch, and I'm going to pause the video here, and you'll see that it starts off very high, the current, and then over time it goes down, 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 until it gets all charged up. And when it's charged up, there's no more current flowing through the circuit. Okay. I'm going to turn it back on again, open that switch, and now I'm going to discharge. And when I discharge, we start with high current, and as those electrons leave the capacitor, the current goes down, down, down. Alright, so charge up, and notice that kind of mirrors what's happening with the brightness of the bulb. It starts off high, and even when we discharge, starts off high, the brightness starts off high, and as the current dissipates, the brightness goes down as well. So that's one way you can remember it. It mirrors what happens in the bulb. You've got charging, and you've got discharging here as well. Both of them start off high current and gradually over time decrease in the sort of asymptote shape. This is an exponential decay. You might have learned about this in maths and calculus, and we're not going to go into it as complicated as what you might do in maths. For now, you just need to be able to remember the shape. Both charging and discharging, the current through the capacitor or through the circuit looks the same. What about the voltage? Okay, so there's two bits of voltage we can measure. We can measure the voltage over the capacitor and the voltage over the bulb. We're going to do both of those. So I can do the same thing. I can bring across a voltmeter oscilloscope. So this measures voltage as a function of time. And I've got another one here, so I can measure the voltage over the bulb. And we start the simulation, close the switch to charge it up. And as that happens, you can see that the voltage over the capacitor grows in time but levels off, and the voltage over the bulb starts off really high, again mirrors the brightness, and then decreases over time. So that does the same as what the current does. So turn the simulation back on again, and we'll discharge. So even now you can see the voltage of the capacitor is still high. As it's charged, it's still got a full voltage, and as it's no current's flowing, the bulb has nothing. So we now go through the discharge, still got full capacitor. I'm just going to switch these over because otherwise it will be negative. Don't worry about that. And as we discharge, you see the capacitor's voltage decreases, and there was a sudden voltage over the bulb because it was bright, and then it went down as well. So the voltage over the bulb, because the bulb is an ohmic, we can think of it as an ohmic resistor, what happens with the current happens with the voltage. Okay, so when the bulb's bright, it has high voltage, it also has high current, and as the bulb gets dimmer and dimmer and dimmer, the bulb has less voltage and less current as well. So that's an easy one to remember. The capacitor, when it's uncharged, has no voltage, but when it's charged up, has a high voltage. So when this was charged, before we discharged it, it went high volts, and then it went down. So the voltage C, voltage over the capacitor when it's charging, looks like this. It increases and flattens off. And the reason it flattens off is we have as we build up more and more charge, it's harder to get more and more charge up there. So it takes longer and longer to increase this voltage by a little bit as it's getting charged. And the bulb, as the capacitor was charging up, started off bright, but it got dimmer and dimmer and dimmer as the current stopped flowing. As we discharged, so the second part of the circuit, we started off with high voltage over the capacitor, and then that decreased down to 0, and the bulb went bright to start with, and then decreased down to 0. So there's two sort of shapes of graphs, and when you put them all in a big summary here, you've either got the thing charging or discharging, and we're either looking at the current or the voltage over one of the two things. So the current, when it was charging, started off high, current was able to flow, but as we built up charge on that capacitor, it stopped current from flowing and the current went down, down, down. And the same thing when we discharged it, we connected it up, and as we did, the light went bright for a split second, it had lots of current flowing, and then it went down, decrease, decrease, as that charge left the capacitor. When we were charging a capacitor, the voltage over it increased, but it petered off as it got more and more charged, and then as we discharged it, we went from high voltage down to 0. The bulb mirrors the what's happening with the current, okay, because V equals IR. For a bulb, it's an ohmic resistor. So it started off with high voltage, and as the capacitor got more and more volts, the bulb got less and less. But when they were the only two in the circuit, when the discharging circuit, they mirrored each other. So when we look at capacitors, you look at the shape of these graphs, 5 of the 6 of them are all the same. You just have to be able to tell and know that when you're charging a capacitor, it looks different. Next video, we're going to go into some simple calculations we're going to do with these graphs, but it starts if you can clearly distinguish and know which graph to choose for which situation.